Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. A prime number is a natural number which has no other factors other than itself and 1. So therefore, the smallest prime number should begin with 2. Then 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97, etc. So these are the prime numbers up to 2 decimal or two digits. For the rest, then there's a technique for that. If it is an integer with 3 digits or integer with 4 digits, so there's a technique in determining whether or not a given natural number is prime. So for instance, is 799 a prime number? Then the answer is no, because we're going to evaluate the square root of 799. So the technique is you have to evaluate square root of 799 using your calculator, because usually the calculator is allowed, especially if you're in the engineering course. So since this is preparation to engineering, then aside from familiarization of prime numbers and characteristics of numbers, then we have to prepare for calculations. So square root of 799 then is equal to about 28.27, and the smallest prime number closest to this is you drop down is 23, not 29. So it should be lesser than 28. The prime number lower than 28, but 28 is not a prime number, of course. So the next one is 23. So we're going to divide 799 by all prime numbers between 2 and 23. Of course, common sense, we have to bypass 2 and 5 because numbers, especially 799, which is an odd number, is not divisible by 2. So we have to bypass that. And the other one is if it is divisible by 5, it is of use. So 799 is not divisible by 5. So therefore, we only divide 799 by 3 or 7 or 11 or 13 or 17 or 19 or 23. If the given prime number is not divisible by those mentioned prime numbers 3, 7, 11, 13, 17, 19, and 23, then we conclude that that number is prime, or else it is an integral number or composite number. So try to use your calculator and you will notice that 799 is divisible by 17. In fact, 799 is 17 times 47. So here is another example or exercise. How many prime numbers are between 400 and 420? So you begin with 401. Square root of 401 is about 20 point something, and the smallest prime number is 19. So you divide 401 by 3 or 7, 11, 13, 17, or 19. And 401 is indeed a prime number. So not divisible by 3, 7, 11, 13, 17, 19. So it is not divisible by those mentioned prime numbers. Then 402 is of course divisible by 2. It's not a prime number. 403. 403 is equal to 13 times 31. Therefore, it is not a prime number. It is a composite number. 404 is divisible by 2. 405 divisible by 5. 406 divisible by 2. Let's proceed to 407. 407 is 11 times 37, so it is not a prime number. 408 is divisible by 2. 409, let's check. It is a prime number. So divide 409 by 3 or 7 or 11 or 13 or 17 or 19. Because 409 is 20 point something, so the closer lower prime number is 19. And it is not divisible by those mentioned prime numbers. Next is 410 is divisible by 2. 411. So 411 is equal to 3 times 137. So therefore it is not a prime number. 412 is divisible by 2. 413 next is equal to 7 times 59. So it is not a prime number. 414 divisible by 2. 415 divisible by 5. 416 divisible by 2. 417 is equal to 3 times 139, so it is not a prime number. 418 is divisible by 2, while 419 is a prime number. Therefore, there are only 401, 409, and 419 prime numbers between 400 and 420. So the answer is 3. Then, which of the following are prime numbers? So 711, 1111. 711 is, I think, divisible by 3. 1111 is divisible by 11. So these numbers here are not prime numbers. They are composite or integral numbers except 1361. So the answer is 1361. You extract the square root of 711, then divide as mentioned by 3, by 7, 11, 13 until the closest but lower prime number, which is equal to square root of 711. Then 1111 divisible by 11, that's obviously divisible by 11. Then this one, square root of 1331. So you divide this by all prime numbers except 2 and 5, and it is definitely divisible by those up to closest prime number, which is the square root of 1331. So it is only 1361 for this case. And I want you to evaluate these first 4 numbers, which are integral or prime numbers. So the answer is only 1361. Twin primes are prime numbers that differ by 2. Example here are 3 and 5, 5 and 7, 7, 11 and 13, 17 and 19, 29 and 31. They differ by 2, 41, 43, and 71 and 73, the last, up to 2 digits only. So 3 and 5, 5 and 7, 11 and 13, 17 and 19, then 29, 31, 41, 43, 59, 61, 59, 61, and 71 and 73. So that's the last, etc. for 3 digits, and so on and so forth. So another example, find the sum of twin primes between 100 and 120. So we're going to evaluate 101. It is a prime number. 103 is a prime number. And since they differ by 2, they are prime numbers. Then another twin primes would be 107 and 109. All the rest are not twin primes, although there are still prime numbers between 100 and 120, but they are not twin primes anymore. So the answer is 420. Then your part, you should have your part in order to make sure if you have understood or learned from this video here. Uh, Although this is light and most of you are familiar with prime numbers already, I hope that for the technique, it will be your first time and you appreciate and you learn how to evaluate whether or not a given natural number is prime. So your part, first question, which of the following is a prime number? So these are the choices and show that the answer is letter D. Then are there twin primes between 700 and 720? Then how many are prime numbers? So 711 is not a prime number. It is between 700 and 720. Then the answer is there is no twin prime. There are no twin primes, none. And however, there are prime numbers, and the prime numbers are there are three, and these are 701, 709, and 719. So that's it, and I hope that you will answer this part here. To make sure, do not leave this part. Answer it so that you will know for those who are first time to determine whether a larger number, integer, is prime or not. Then twin primes, of course.